All right, let's go ahead and get started. We ended a little early on Thursday. I wanted to talk about Mirai botnet, but just to kind of set the context of our prior topic that we're sort of finishing up or have finished up, we were talking about IoT security. And really, a lot of the focus was on what really differentiated that particular smart device security from that of just regular computing network security. And there were some subtle factors, but certainly one of the factors was the ubiquity or the scale of those devices. We talk about an internet of these things. Kind of implied in that name is this thought that there are many, many, many of these type of devices out there, which the quantity has a certain importance in and of itself. And so we talk about this idea of you have many of these devices. They're potentially, for various weaknesses, insecure in one way, shape, or the other. That can consequently lead to many infected devices. So while a botnet is not necessarily limited to IoT devices, some of the most impressive or effective botnets that have occurred and have propagated have been based on IoT devices. Botnet is just a group of devices that have been infected by some particular piece of malware. And then what makes it a botnet versus just a virus that is spreading is that there's some sort of control server. There's some sort of malicious actor who isn't just setting it off and allowing the malware to spread, is also maintaining some aspect of control of the resulting devices that are infected. So bot as in robot, net as in network, that's all that a botnet is. And these two concepts do kind of go together, IoT security and botnets. And that's why when we did the IoT security lab, because ultimately there wasn't really that much different in terms of what it looks like from a computing perspective. It's a computer, a processor running an operating system. That's what we kind of tried to explore a little bit in that lab, was looking at the botnet side of things. One thing you would have noticed in the lab as you are working on it is it wasn't quite as simple as just saying the botnet is one particular device. There's at least two, oftentimes three separate sort of classes of devices that are associated with a botnet. The Mirai botnet is still probably the most famous example, so this is just an image, a diagram of someone trying to break down the structure there. Here, what you have is, at the very least, you have some sort of scanning, some sort of malicious malware loading machine. That could be, your own personal workstation. It's the computer that's trying to determine where to sort of kick off this infection cycle you have here. So your scanner slash loader, that literally just means something that is performing some sort of network scan to determine what devices are out there that have a particular vulnerability, like we've already been doing, and then loading the payload. So that's our starting point machine as we've been using it all semester. Then you have the actual IoT devices themselves that are then the target of the scan and then that loading operation there. What differentiates botnets from just other potential propagation channels is then there's also this sort of third machine here, or set of machines, that are meant to be deployed after that initial point of infection. Those are the CNC machines, or the command and control machines. And those are the ones that are communicating with the already infected machines and basically providing, via some sort of application layer protocol, what the next thing, what the next target, the next task for these infected machines. We are infected. We have some sort of remotely accessible software now running on it that was initially intended. You still have to stay somewhat subtle. You don't want it to be doing something so obvious all the time. We occasionally check in with the mothership. We check in with this command and control machine or set of machines saying, what do I in fact do next? And those commands could be as simple as look for more vulnerable machines. I mean, that's a very common command. You yourself are infected. Now you're not just an infected device, but also act as your own scanner slash, at least scanner if not loader, and look for other devices that may also be potentially vulnerable to allow it to spread further. Or eventually at some point, you have these number of devices that are all infected with Mirai or some other botnet, and at some point, the bot master, the commander of this network, is saying, now go do something. Ultimately, when you have this many machines, and 150,000 devices is sort of the peak of the Mirai botnet here, usually you have a quantity of a number of these devices. They're all network accessible devices. The most common thing you'll see with them is then to perform some sort of distributed denial service. You have 100,000, 150,000 devices. That is a lot, depending on how much bandwidth they each have. If they're all working in concert to attempt to take down one particular service, they're going to be quite effective in doing that. So your 1 terabits per second of distributed denial of service traffic is something that today I think Cloudflare and other services have kind of grown to be able to maybe prevent and support those under that type of attack. But at the time, that was a significant amount of DDoS traffic here, and the type of services that got hacked. They were looking at, if you ever heard of DNS, that was a popular kind of publicly available DNS registration service that a lot of companies were also using. So if you attack DNS, then you're potentially taking down these other services as well. So it was pretty effective because of just the scale of the number of devices in taking down DIN and other cloud providers. That's not to say that's the only thing one can do with a botnet. And certainly in our lab, we don't want to do denial of service. We can just send some packets and see what happens. But when you have IoT devices, and the idea is for a given vulnerability, it's not just 200 computers that are affected, it's 200,000 computers that are affected. And then plus, in addition, all the other things we know of being kind of unique to IoT security, then that's a potential outcome, that you have N number of devices that are now vulnerable, that are now under the remote control of some command and control server and some bot master. Now what can you do? One thing you can certainly do is try to take down other services here. We had previously looked at the OWASP top 10 for web application security. They also maintain an IoT top 10. And unlike with the web application one, in which we went through every one and tried to walk through some examples, for this, it's probably sufficient to say, what is different between this and the software web application top 10? And there's a couple things, some of which we've already talked about, like number 4, lack of secure update mechanism, potentially by design or more likely due to kind of economic or financial constraints. These devices are kind of built in an almost disposable way. They're built, they're sold, no one wants to support them after the fact. So if you don't have well-established mechanisms to do the equivalent of your apt-get updates and installing package updates for vulnerable components, that is a separate vulnerability pathway that doesn't exist to the same extent in traditional computers. There's a couple others that I think are more unique to IoTs. We've talked about physical security as being an important consideration, where if you lost your laptop, if your laptop's stolen, even if you have full disk encryption, there's some real risk of loss of data. But for these devices, the difference is really that they are meant to be, to some extent, physically accessible by their very nature. They are embedded smart devices. They're embedded in something physical. Whether it's as trivial as saying it's something we can just easily reach out and touch depends on what particular type of device it is. But by their very nature, physical access can't be necessarily gated off and completely protected. They're in the public. They're meant to be out and about for them to be serving their purpose. So lack of that physical hardening, preventing people from having that type of low-level physical access to break into it. And there's a couple others here, but the other one that I think is unique to IoT devices is sort of hard-coded or weak or guessable passwords. In the OWASP top 10 for software applications, there was quite a bit of discussion of flawed authentication approaches. And this is also a flawed authentication approach, but it's a bit more fundamental than that you have these devices, and this is maybe less and less the case now, but you would have a device, you would buy a web accessible camera or a new router for your house, and every single device that was sold was sold with the same hard-coded default password. And perhaps the instructions would say, hey, you've unboxed this device, make sure the first thing you do is you go in and change your password, but it wasn't necessarily enforced. Or if it was enforced, there weren't kind of the well-understood aspects of providing some password difficulty in terms of automated cracking. And if we looked at what Mirai was able to do and how it was basically able to infect so many smart cameras and the like, it was just common passwords. It was the same thing that we know is the case, but is maybe, like we mentioned, something that had to be kind of relearned in this field, something that we already had learned in sort of traditional general purpose computer security here. I don't love doing this, but this is kind of the last I have on this particular topic, and I want to jump into our next topic, which is what you've been working on in this most recent lab, which is auditing and remediation. So I would say we've fallen behind. I mean, you're kind of done now with sort of the 1 week basic lab. So we're still kind of on pace with both in-class topics and lab topics. This is, the last in-class topic that has a direct lab associated with it. So just even though you're finishing it up or have already finishing up for those who are in today's lab, maybe we're a day behind, but we're pretty good in terms of our overall schedule here. Really, a lot of auditing, at least, is all about just reviewing logs, like you've already done in prior class, SciB 2300 or 230, just to determine what things have already happened in your system. That's the auditing side. Remediation side oftentimes has to do with you have discovered a vulnerability. What do you do next? How does one patch vulnerabilities? With the understanding that we are not necessarily the developers for any of the software packages that we're using. We are just users, we're consumers of those software packages. So we're not taking it from the perspective of how do I, as a developer, patch my heap or use after free bug in my code. More so, I'm a user of software, I'm an administrator, I'm a security consultant or professional. How do I then use existing channels to remediate my vulnerabilities? This isn't directly having something in the textbook associated with it, but I think we'll be able to figure it out. We'll try to have a little fun with it as well. And then starting this week in lab, this is your multi-week final project. I'll be curious to see how it goes. I think for some of you, it'll be very straightforward in the sense that you are applying the same exact techniques that you've been doing in the lab since week 2 of the semester on a whole different network. If you've been following along, I'd say if you've been taking notes about what you are doing in lab, you're going to find it pretty straightforward. Now, if you've just been, and I've talked about this a few times, how it is feasible, you've just been copy, paste, command, copy, paste, command, copy, paste, command, you're still going to be okay, but you can't do that again. Now you're going to have to go back and try to review what you had previously done and gain a little bit more understanding of what you previously did to then apply it in, frankly, a very slightly different set of scenarios than what you did it the very first time. And maybe a lot of you will fall somewhere in the middle, where some steps you did really understand, other steps you kind of got through and got the stuff submitted by the deadline or as quickly as possible. So maybe you'll fall somewhere in the middle, but it's really the same things as what we already did, but now without that kind of line-by-line guidance that we had in those prior labs. So it's not necessarily new tools or new techniques. It's let's just apply it for a network in which I don't tell you exactly what the outcome should be every step along the way. That starts this week in lab. We'll see how it goes. So what is an audit? When we talk about auditing, it's just an official inspection. The term is more commonly referred to in sort of the financial world, checking if standard practices are being followed. Oftentimes, an audit is performed by sort of trusted third parties. And so you have these companies and very large, very successful companies that exist to perform auditing of other companies. They don't audit themselves, or at least that's not considered best practices, that instead of confirming that you yourself are following best financial practices, at least in this context, you hire someone else, you pay quite a bit of money to get them to do that auditing for you. You basically open up the books to a trusted third party. Also for things like making sure you're following various regulations and certifications. So if you want to think of what auditing looks like in the financial world, think of Accenture, formerly Andersen Consulting, which is a very successful company. When auditing goes as expected, you don't really hear about those companies. Now, Accenture hires lots of cybersecurity professionals, and they have that need as well. You usually only hear about auditing companies when things go very badly. So if you want to look at the history of, say, Arthur Andersen and Enron and WorldCom and all the problems they had there, that was an example where the auditor was basically telling the company what they wanted to hear. They weren't trying to tell and unveil the real truth of the financial situation. That's auditing in kind of the financial world. That's where the term is coming from. It's also applied towards your IT, your computer systems, because there's a lot of things beyond just vulnerability checking that you'd want to be auditing. Things like your processes and procedures is something that a third-party audit makes a lot of sense for. The existing security posture of the company in terms of what rules are currently in place. And then separately, we like to do auditing of the actual access logs of a system. who has attempted successfully or unsuccessfully to access various services and resources in your organization. And the idea is that we have these tools that already exist that are going to be generating these logs, these data trails, and that it's then has to be someone's responsibility, either in real time or in a periodic nature, to determine, what has happened, what was the truth of the access for your particular systems here. And we'll talk a little bit about what that means just from a Linux sysadmin perspective. Um, but you should note that there's a whole sort of industry market segment that is, for want of a better term, they're sort of log processing companies. The idea that you have these software services, and this is just an example of just very basic Linux 101 software services, that what kind of log files they may be creating here. There's all sorts of, any system, any service, anything you're running is going to be generating logs. And so there's whole companies that exist to process, to intake those logs and provide some sort of actionable intelligence. Here's my terabytes of log data that I'm generating per day. Again, whether it's in real time or whether it's on a periodic basis, providing some sort of intelligence saying, well, you're under attack, or, well, you're having people accessing things they shouldn't be accessing. There's not one size fits all solution for whether it should be sort of live auditing or whether it just needs to be kind of on a periodic basis. Um, it's something you would also contract out for these tools that are professional tools that allow you to kind of read through these logs and grab only the information that you need. Because once you're at even any sort of scale, and even just a single user Linux operating system running just your own stuff on it, it's not something that's really meant to be human readable, at least all at once. It's usually text format, although not always the case. Usually it's textual logs, but the scope, the size of these logs is not something that you're supposed to be kind of just tabbing through and trying to just read on your own to determine if something happened. So these logs are in all sorts of places. /var is one place for where variable files go here. There's no, for anything I put up there about Linux, there's a distribution that does it differently. It's not a hard set fact, but this would be in one set of distributions where these things would go. And while, again, there are these sort of professional tools that basically exist to consume custom logs, you can do a lot just with like sort of command line skill set, and that's something that I don't know if I'm preaching to the choir in this class. It really depends on your, academic background, just your own personal interests. It's very much a superpower that people don't realize, that, you can just treat it as kind of just a blind input-output relationship of this command does this and this command does this. As you get a little bit more adept with it, you'll just find yourself just a much more productive, human being, a more productive, user of a computer. You can always write a program in Java and Python and whatnot to do this kind of processing. But this problem, this understanding that we have these logs and we need to have some semi-automated way to consume those, to search through those, to transform those logs, that had led many, many years ago now, decades ago now, to the invention of a series of tools that are still very state-of-the-art in terms of processing that data. This example is a very basic one. Maybe we can spend some time and I'll get a feel for how well you know how to do this already. This is a very basic example of using the grep tool. So looking for a particular pattern in a file or a set of files here. In this case, we're looking at /var/log/auth-log. And this example is a little silly, but it's attempting to show if you have your SSH daemon, it's checking all the remote login attempts on that particular computer, and it's looking for the string invalid user in that. And this is something that you couldn't necessarily know without reviewing it at least manually one time. Let's look for any lines in that file that match that particular string, and let's look a few lines before that entry. So give me the 3 before lines and give me 1 line after that entry. Give me that relatively closely located chunk of log data associated with that login. At the very least, that gives you an idea that there has been or a certain number of invalid logins on the system. What you do with that next really depends, right? You can take the IP address that's associated with it, perhaps then you add that to some fail to ban type script or something like that, or you just log that separately in a separate file. There exist a number of these utilities, of which There are, there's classes that help you gain familiarity with them, but they were invented explicitly for that purpose. You can always write a standalone program to do all this. These utilities exist. They're meant to be composable with each other. You can do a whole lot without writing a line of quote unquote code, but you need to understand a little bit more about the relationship of these utilities. You really just need to gain a little bit more appreciation with sort of Linux command line, bash scripting. I had asked that in our first quiz of the semester, if you remember, kind of self-assess yourself on a scale of 1 to 10 of how familiar you are with this kind of thing. And it was kind of bimodal. And so I don't know which mode I'm talking to here today in class, but the video is available. People can review it afterwards. There's classes, ComSci 252, 2520 covers a lot of these sort of things. It's worth learning. So even if you don't have to take that class, or have already taken it and forgotten it, or aren't interested in taking that class, you will really kind of level up just your computer skills, your usefulness as an engineer and as a human being via some quick learning of those particular skills. One aspect of that doesn't get taught very well is how we can use these search strings to look for more complex patterns. Who here has learned on their own or in class how to use regular expressions? A show of hands. And I understand if the hand is only half up. I get that. Okay, yeah, that's totally fair. That's one of those topics where you can get started and learn a little bit, and then true mastery maybe takes quite a while, and so we still have to look up these kind of things. Regular expressions, regexps, are a way of providing a little bit more of sort of a syntactical pattern for what we want to look at. And in computer science, there's a whole lot of theory applied to it. You can learn about finite automata theory and how these matching algorithms actually would work in practice. As a user of regular expressions, you will find them to be basically a very powerful tool. Again, if the string you're looking for is just the string hard-coded invalid user, then regular expressions aren't necessary for that case. But if there's various patterns for which it's very hard to kind of expand upon all the possibilities of those patterns in something you're searching for or wanting to consume or wanting to transform, then using regular expressions will make you just a much more productive person. I was trying to find a good resource on regular expressions, and I can always provide links to these. There are a lot. I think this is recognized as not a problem, but something that isn't taught especially well, or it's just hard maybe to teach yourself regular expressions. So as this particular topic on auditing and remediation isn't super chock full of technical content, I thought we can give this a try. This is regex 1, which has a lot of tutorials and lessons on how to use regular expressions. Let's do this together. Let's go until we get stuck. I don't know how long it'll take. We may find this is very easy, so be it. We may find that you'll discover you have a couple gaps, and it would be good to learn these sort of things. So we're processing as input some text. Again, the context for why we are doing this is for auditing. We have all these logs, and who knows, kilobytes, megabytes, gigabytes, terabytes of logs. We don't even really know. We want to find some information in those logs and perhaps do some further transformations of that particular data. And what we're looking for is not as easy as just looking for the string invalid user. If that's all you're looking for, you don't need a regular expression. You're looking for particular patterns for which one could, again, write some software code, write some Perl, write some Python, write some Java to do all that, and maybe write a 100-line program to do it. We have these tools that already have parsing of regular expressions sort of built in and fundamental to their nature. So if we learn how to use those particular patterns, then instead of writing 100 lines every time we want to search for something, we can just write a little shell script or just do it directly on the command line. We have done a little bit of this in the labs this semester, but it wasn't as obvious that that was the case. You were just kind of using those commands and seeing the result and screenshotting the results. So I thought, let's give it a try. We'll start early, easy, and figure it out. So each one is kind of going through a lesson that it's just text to start with. If I want to look for the string ABC, I put in ABC as my regular expression that I am looking for. So we want a pattern that will match all three of these rows here. I don't know if you guys see that okay, or you can just follow along on your own if you go to that website. So what pattern will match all three of those entries? Just ABC. Okay. Hey, we already got through the first lesson. If you want to match particular digits, again, digits are also just text, but if you want to match any particular digit, you can then use /d. So that's the first example of using something that's not just string matching anymore. Now it's regular expression matching. Again, this would actually work if I wanted to do 1, 2, 3. That would also work for this example because it's both digit as well as text here. So I could match it that way. But if it wasn't necessarily 1, 2, 3, if it was I wanted to match 1, 2, 3, or 3, 4, 5, or 6, 7, 8, what I would actually want to do here is match in my string if there's any digit character. And there's 3 of them. There's going to be more than one way we're going to see how to do this, but for now, /d/d/d, we see find me anywhere in those strings that you see 3 digits in a row. Either answer is actually fine. So, as with coding, right? There's not like one way to solve a particular problem. There'll be then people who have very strong opinions about what is the correct way to solve a particular problem, but it's not required that it's necessarily the case. Also, a concept of the wildcard, which is the dot character, which is meant to match any single individual character in our string here. So that is to be disambiguated with just actually matching the period itself. So if I do this, that would match all of them. That wouldn't. That should not work here. If I wanted to just match, can match the first 3 strings, but not the last one, we can actually say, well, that's why that worked. This would match everything. Dot is just match all. It's like in other contexts where you're just doing basic string search, that's just wildcard. That's your wildcard in your regular expressions. If instead, and that doesn't work because it matches the first character. In all 4 of these, we want to skip the last one. What do all the first 3 have in common? They have the period character. We actually do a match for just that period character. Okay. Take a moment. Person next to you. How would we match this one? If I want to match a particular range, you can specify that range. If I don't want to match a particular range, you can also say I don't want to match that particular range. First thought would be I want to match just AN. That's not going to quite work because it matches all of them. They all have AN. So how do I tell it I want to match just can, man, fan, and not the last 3? Yep, brackets. What do you want to put in them? The 3 that we want to match. Or alternately, if we say I don't want to match DRP, I may be getting this wrong. I think it's just the tilde or the whatever it's called, the caret character, and skip DRP, then match AN. That's your first kind of like real regular expression here. So we want to match those first 2, but not the last one. Again, you're going to see here that there's never going to be just one option for most of these things. There'll be lots of ways to match them. What would this one then wind up being? You guys can read that. It's interactive. I know that's part of it, right? Doesn't work because that matches all of it. Yeah, and you could do that, or again, if we're, and again, they're both correct, or not B is basically what we're matching for that one. It's also correct. They're both totally correct. Is this okay? Should we do a couple more of these? Okay. Okay. Now using that bracket syntax, and you'll see a lot of examples this way, you can then provide a range of characters. So you don't have to type out every single character you want to include or exclude. So the example given here in this very brief explanation, if I want to match just the characters 0, 1, 2, 3, 4, 5, 6, you put it in brackets with a dash in between. Likewise with I don't want N through P, you use that brackets with the dash syntax to include it. And then it's also case sensitive here. So How would we do that? I mean, there's lots of ways we could do this one. How do we get it that we want to match A, B, Anna, Bob, whatever, those three with a capital? We don't want to match those three that don't start with a capital letter. Yeah, we could do A, B, C, which is correct. I think this example is meaning to show that you can also do then A through C, and that would also match those three. We'll do a couple more. Um, so now this one's showing the repetition syntax. So this is the whole point of regular expressions, right? It's a sort of a technical way of specifying a pattern versus just specifically, again, searching for the one particular string that happens to match part of what you're interested in here. These examples maybe aren't difficult enough to really justify the use of regular expressions because there's just 3 or 5 or 7 options here. When you have 500,000 entries in your file and it's really particularly what you want to look for, then those expressions are going to become a little bit more value here. So with our bracket syntax, we can specify how many of those matches we want to have here. We already talked about the dot being the wild card. You can do just a single pair of brackets to say I want exactly 3 times, or you can specify I want to match the character A between 1 and 3 times, and any one of those would work. So for this one, we're wanting to match was up with more than one Z in the middle of it. Again, you probably can start as you're trying to construct what would work with matching, you know, something close to what you're interested in, right? That's not correct yet, but we know that's matching at least the starting point. And yes, technically, because we're not caring about what's at the end, we don't really care about what's after the Z's. But still, for completeness sake, if you want to match the entire string, you would include it there. We want to match what? Not one of those values. So between, well, how specific we want to be, 2 and 6 or something should work. So it's not just Z we're wanting to match, we're wanting to match more than one Z. And I think there's an option for just more than one Z. So that should work. I think then if we also did, one or more would not work. You could probably do Z plus would also work. So I want to match a single Z and then one or more additional Z's. But I think this lesson is suggesting we do, with that bracketed range of between 2 and 6 of those Z's. Right? If we had just done 2 to 4, it wouldn't match the first one because it has 5 of those Z's. Okay, so 0 or more or 1 or more of those characters. And again, here's where the syntax looks different than like wildcard matching in regular strings. Now the asterisk or star operator is referring to 0 or more repetitions of something. The plus character is referring to 1 or more repetitions of those things. How would we do this one? Let's take a moment. So don't just let me figure it out. I know how to do these. Take a moment, think about it. How do we get it to match this? Can't just do A. That doesn't work. It matches that last one. We could do AA. That technically works. Let's say if we want to match the entirety of the, you're right. So I think the correct spirit of these exercises, we want to match the entirety of the string and not just the first thing that causes all the strings to match. So not just AA, but now AA plus, our grades in this class, agreed. What about our B part then? What should that one be? B star, absolutely. 0 or more Bs, C plus. Grades of everyone who's not here today in class. So this is just showing the optional character, that's the question mark operator. such that if you actually, just like with the period, if you actually want to find it, you then have to escape that special character. So for this example, again, let's do it properly, but this actually technically would work. If we just want to find the question mark character in our string, how else could we match then the entire pattern here? We have one file, two files, 24 files. How do we match 1, 2, or 24? Well, it's a digit. It's how many digits? One or more. Slash D plus. It's complaining, but it shouldn't be. Plus a space, file, an optional S. Thank you, because I was having trouble with that. Optional S. Looks like it's saying files. No, but it's files where the S is optional, so either match an S there or not. Another space, found, and then now the actual question mark at the end would be the match for that string. Use your new superpower wisely here. Okay. So white space matching is actually kind of a tricky thing, and it's a very common thing that different tools will insert tabs, versus insert new lines, will insert just extra and variable amounts of white space in the log. Some tools try to kind of align the output, others don't, and they're not caring about sort of human readable output. So matching variable amount of white space is an important thing here. So there's a white space character, which is /s, which technically works because the last example doesn't have any white space. But if we want to match this exactly, what's the first thing we look for? Digit. Actual period, right? That has to be escaped. A variable amount of white space, but it looks like it's one or more white space characters than A, B, C. Describes both the start and the end of the line using the hat character for the start of the line and the $sign for the end of the character. You can create a pattern that matches the whole line completely at the beginning or the end. This is different than, and it's kind of annoying, and there's only so many characters we have to work with here. When it's the hat inside of a bracket, that's the exclusion rule. When it's a hat by itself, it's saying match it at the beginning of the line. What would it look like for this one? Somebody else who hasn't volunteered. Sure, you've already volunteered, sure. Fine, go for it, Go as far as you want at that point. You could also then, I'm trying to remember do I put the dollar afterwards or before for the end of the line? I think it's at the end of what I want to match. Yeah, and that should then match that. Whereas if I just to show that, if I just done successful, that would match those first two because that's successful at the end of the line. That is different than just matching that string anywhere in there, which would match all three of those. Now I got to go back to what was working. Okay. I think we're almost done. We've gotten through this entire tutorial. So you can match the text, but also extract and capture that group for further processing. So in this example, if I know there's a set of files of images and it's going to be the IMG at the beginning of it, then a certain number of one or more digits, then the period PNG at the end of it. It allows you to extract the full file name and then allows you to grab that particular pattern here. So try to match regular expression that matches only the file names of the PDF files alone and then provides sort of the non-extension part of it. So the parentheses are saying, still part of the match, capture that part of it for further processing for some additional tooling that can take advantage of that match. So we know, without the capturing part, we know we want file, and we know we want .pdf at the end. Now, the reason it's not happy about that is it's the capture part. We'll get to it. Match the value file at the beginning, have .pdf at the end. How do we capture what's afterwards? Any thoughts? So how do we capture here? I'll move this stuff to the end, the .pdf file. They're different looking, right? All we know is, at least for now, and actually there's no guarantee it starts with file, but that's what this example is showing. Starts with file. Right, because it could potentially be called file.pdf, I guess, right? So any character with 0 or more repetitions followed by .pdf. So that consumes everything in the middle. Then it also is explicitly matching. So this is getting a little messy, but so be it. And it's not the same as a regular string match with wildcards, right? With wildcard characters. Any character, period, 0 or more of them, although this example, maybe we could have done 1 or more, file.pdf would also then get caught. We also then want to actually capture the actual period, the .pdf, that's \dot. Now we actually want to extract all the stuff that's after that beginning, which is everything before the PDF, the .pdf. Excuse me. That's what those parentheses are providing. You're getting hard. We'll try one more, and if we declare failure, so be it. Now, if you want to capture more than one thing at a time, or if you want to both capture some outer information as well as some information within that information, you can do nested parentheses to capture nested groups here. Where in this example with the camera file, you're capturing the name of the file like we just did, and then you're separately capturing the number information separately. So you'd get image 1, 2, 3, 4, 5 as a capture, and also then 1, 2, 3, 4, 5 as a separate capture here. So what would this one then look like? There's going to be a lot of different options for this one because it's really just focusing on the capture. How do we capture that to start with? Somebody else. What does it start with? I would say A through Z should be able to capture it, followed by what? And I actually don't know if it's 2 of them always. I mean, I guess you do have to know your data, right? You can't just blindly write a regular expression and hope that it works. You have to look at your data and see what the actual patterns are. 3 isn't necessarily enough for anything other than a simple trend. Fine. We could have put all of this at the beginning as well, but the way we're doing it is fine. Capture a white space, or just the space is fine. What next? A digit, and I think it's probably 4 digits each time for a year. Again, there's no guarantee it's the case. We want to then capture the whole thing, unless I'm missing something here, and then we want to separately capture the 4-digit year that we then have here. I have to retitle today's lecture to regular expressions. There can't possibly be too many more. Okay, you already got through them all. Oh, you can see, well, maybe there's some extra special ones at the very end. We have time. Okay, so there's a lot of flexibility here. You can also use non-capturing groups, which allow you to match the group but not have it show up in the results. Here's a common different display resolutions. Try to capture the width and height of each display. Okay, open to your suggestions. I'm tapped out in my skill set here. How do we start? I would do the match first and the capture second. At least that's how I usually think about these things. Because once you're matching, then you can capture. How do we capture the first part of the resolution? Yeah, and I think 4 is fine. Probably trying to think if there's any. Yeah, it could have been 3 to 4 if we want to be really technical. Oops, it's fine. But, oh, those are all 4. What else? Are there any 5-digit resolutions? I don't think so yet. Not in like standards, at least as of yet. What else do we have to capture? Just an X. Then another set of digits, 3 to 4, of which we're supposed to capture these separately. But for all of these, we don't need the question mark itself, so that should just work. I don't know if they were looking for something different in that one. Looks great. Okay. This is showing the pipe operator, the Boolean kind of OR operator. So I love, think I have to put it in parentheses. I love cats or dogs. Special meta character \B. I don't even remember that one. B is just word and non-word character. This will be our last one. This one's a little tricky. So using these to kind of match words and non-word characters here, as well as the special characters. I mean, there you go, we matched them all. But that's probably not what they're looking for this particular example. If they don't put any non-matching here, well, that one's not very useful. Oh, we'll do one. No. One more additional. Okay. This will be our last thing. When we get this done, we can be done today. How do we match? Again, without a skipping pattern, it's too easy to kind of skip over these. So we have to skip 720p, but all those other numbers we want. How do we do it? So not. That is still unhappy. It's matching. No, but no, that's not going to work, right? That'll. No, that's at the beginning of it. Okay, wait, let's think this through. Hold on. Okay, you're right. With any of these, we can be really difficult. Anything that doesn't have P at the end should match. Start with anything and end with P, not end with P. It's end with not P. Hold on. This is difficult. There you go. That feels like that's cheating to me a little bit. But we've been cheating on a couple of these so far. Don't end with P. We want to match the entire string. You could just say begin with what? Any number or a negative or a dot or a comma and have and match one or more of these. And there you go. That's probably a good enough match. I'm curious what their solution wound up looking like. Not terribly different. They're just giving all the different possible options because it shouldn't probably start with E, wouldn't be a valid number. So you probably need to start with a negative. That's what they're doing here. Start with an optional negative, then one or more digits, then include commas or periods or an E somewhere at the end, and have an optional ending, which is capturing the base and the exponent separately here. let's leave things here for today. We've very, very slightly leveled up our regular expression skills. Maybe we'll do a little more, not of regular expressions on Thursday, but some more just making sure we understand what it means in practice to be working with these files and working at the command line.